So in continuation of electrostatics, in last lecture, capacitor of capacitor, uniform dielectric medium, then partly air medium and composite dielectric medium. So we derived the equations for that for different dielectric material for the parallel plate capacitor. So for the uniform, we got C is equal to epsilon 0 into epsilon R into A by D. For the partly air medium, we got C is equal to epsilon 0 into A divided by D minus T by epsilon R. If T equal to 0, then we have C is equal to epsilon 0 A by D. For the composite dielectric medium, as we know the equation field intensity, we can write E is equal to V by D. So according to that, we'll get epsilon 0 into A by D1 upon epsilon R1 plus D2 upon epsilon R2 plus D3 upon epsilon R3. So this is the capacitance equations for the parallel plate capacitor when we use different dielectric medium between two parallel plate of capacitor. So accordingly, we can store the charge. Now we'll do some examples. Okay, in examples here, you can see the statement. A parallel plate capacitor. Okay, this time. A parallel plate capacitor has plate area 4 centimeters square. The plates are separated by 3 slabs of different dielectric materials of thickness 0.3, 0.4 and 0.3 mm with relative permeability 3, 2.5 and 2. Calculate combined capacitance and dielectric stress. So which dielectric medium is given? Uniform, partly air or composite?
Composite.
Yes.
Composite.
Yes, it is composite. It is given 3 slabs of different dielectric materials. So it is composite dielectric medium is given. Okay. So we have to use capacitance equations for that. Okay. C is equal to epsilon 0 into A by D1 upon epsilon R1 plus D2 upon epsilon R3 plus D3 upon epsilon R3. So area is given 4 centimeters square. Convert into meter square. So 4 into
10 raised to minus 4.
10 raised to minus 4.
4 into 10 raised to minus 4 meters square. Thickness 0.3, 0.4, 0.3 given means which? What we can write for thickness? For the thickness, we have write D. D1, D2,
D3.
yes, D1, D2, D3 given 0.3, 0.4, 0.3 given. And this permeability denoted by
ER1, ER2,
R1,
ER3.
epsilon R2 and epsilon R3. So this is given. Okay. Now we know the equations. C is equal to epsilon 0 into A divided by D1 upon epsilon R1 plus D2 upon epsilon R2 plus D3 upon epsilon R3. That is your combined capacitance. So we have all the values for the area, thickness and permeability. So by substituting these values, we'll get this answer 8.64 PF. We know this absolute permeability 8.854 into 10 raised to minus 12 into 4 into 10 raised to minus 4. Okay. So just check from your side. Are you getting this answer or not? 8.64 picofarad. Pico means 10 raised to minus 12. Okay. Micro means 10 raised to minus 6. Okay, so can I move to next slide? Are you getting this answer?
Yes, sir.
Yes, sir. Yes, sir.
Any error or
Yes,
mistake?
sir.
Is there, then
Yes, sir.
correct it. Okay.
Yes,
So
sir.
we have to find dielectric stress. Here, not ask for the different dielectric material. Okay. So you can find for any material. Okay. Suppose I am finding for E1, E2 or E3. If you ask find out the dielectric stress for all three dielectric material, then you have to find E1, E2, and E3. But here only just ask find out the dielectric stress. So you can find for any slabs. Okay. So for that, what you need? For that, you need here we need voltage. So voltage is not given here. Okay. So for that, we need to find charge. So for the charge, we need voltage. So we are assuming here voltage 1000 volt. So by assuming this 1000 volt, we can C into V. So that is 8.64 into 10 raised to minus 12 into 1000. So 8.64 into 10 raised to minus 9 coulomb. Okay. So what is the need of finding this Q? Because after that we need flux density. Flux density equation D is equal to flux density
Q
is
by
given.
AM.
D is equal to
Q by A.
Q by A. Okay.
Pulse by
Yes. And dielectric strength or electric field intensity is equal to
D by epsilon 0.
no. And we
D
also
upon epsilon not into E.
yes, E is equal to D upon epsilon 0 into epsilon R. We know the relation. D is equal to epsilon 0 epsilon R into E. Okay. So according to that, we can write. So flux density D is equal to Q by A. So 8.64 into 10 raised to minus 9 divided by this area 4 into 10 raised to minus 4. So we have the answer 2.16 into 10 raised to 5 coulomb per meter square. Are you getting this answer? Just check from your end. 2 into 10 raised to 5.
Yes, sir.
Sir, 10
Yes,
की
sir.
Yes,
Yes,
10
sir.
raised to
minus 5.
this is 10 raised to minus 5.
Minus 5.
Minus
That is why
10
5.
raised to
I am
minus
asking.
5 it should be.
Yes, wait. This is your 10 raised to minus 5. Okay, this is 10 raised to minus 4. This is 10 raised to minus 9. Okay, so we have 10 raised to 5, 10 raised to minus 5. So just correct here. This is your 10 raised to minus 5. Okay, now we know the relation between flux density and intensity. D is equal to epsilon 0 epsilon R into E. So according to that, we can write E is equal to. So here, find out the dielectric strength. So just we are finding for the only one slab. If you ask dielectric strength for each slab, then you have to go for E1, E2, E3. Okay. So E1 is equal to D upon epsilon 0 epsilon R1. So 2 into 1 6 into 10 raised to minus 5, 8.854 into 10 raised to minus 12 into 3. So that is kV per meter. So similarly, you can go for E2. E2 is equal to D upon epsilon 0 into epsilon R2. E3 equal to D upon epsilon 0 into epsilon R3. So we'll get this dielectric strength for different dielectric medium. Okay. So in statement ask find out the combined capacitance, that here we found this combined capacitance, and ask dielectric stress. So for that we need charge Q, then we need to find the flux density, and then you can find field intensity. You can also solve by other method also by knowing the relationship. Okay. Now second example is given. A parallel plate capacitor has plates of area 2 meter square spaced by the three slabs of different dielectrics. The relative permeabilities are 2, 3 and 6, and the thickness 0.4, 0.6 and 1.2 mm respectively. Calculate the combined capacitance and the dielectric stress in each material. here ask in each material. So you have to go for E1, E2 and E3, okay? So before solving the example, just read the sentence carefully, okay? Then and then just start your calculations. Here supply voltage is given, no need to assume, okay? 1000 volt. So in the given data, which parameters are given?
Area.
Area is
Area.
given.
Area.
So 2,
So D given.
yes,
And
2 meter
epsilon
square
R.
is given. So this statement we want to convert into the diagram, then we can draw like this. Three dielectric materials are given. Okay, so permeability epsilon R1, epsilon R2, epsilon R3 is given. Thickness is given 0.4, 0.6, 1.2, and 1000 volt is given. Okay, across the plates of capacitor. So area is given 2 meter square. Epsilon R1 is given, epsilon R2, epsilon R3. D1 is given 4.4 into 10 raised to minus 3 meters. So all the data are given meters. So no need to convert D2 and D3. Okay, so this is given in mm. So just we are converting into the meter. 0.4, 0.6, and 1.2. Okay, this is 236. Now similar, just find out the combined capacitance. Just find out according to the equation, C is equal to epsilon 0 into A. C is equal to epsilon 0 into A divided by D1 upon epsilon R1 plus D2 upon epsilon R2.
2.95 into 10 raised to power minus 9.
Wait, what you are getting? 2 point
2,
95 into
9,
10
5,
raised to minus
2
9.
minus 8.
10 raised to minus
8,
9.
sir.
9
9,
or 8?
9.
8 I
9.
have.
8.
Okay, I am writing 8. Okay, and unit
Where are you?
farad. Okay, okay, I am writing farad. So remaining ones, are you getting this answer?
Yes, sir.
2.95 into 10 raised to minus 8 or 9?
8. 8.
Minus 8.
8.
10 raised to minus 8. Okay, so I am showing you this answer. So this is the equation. Just we are substituting all the values. So in other way we can write 0.0295 microfarad. Okay. So by shifting this point, so just 0.0295 into 10 raised to minus 6. Okay. Or you can write 2.95 into 10 raised to minus 8 farad. Okay. So the answer is right. 2.95 into 10 raised to minus 8 farad or 0.0295 microfarad. You can write like this also. Okay. Yeah. All of you getting this answer?
Yes, sir.
Yes, sir.
Yes, sir.
Anyone have query regarding to this solution? We are solving this. You need to remember equations, this relationship. Then and then you will get this correct answer. Okay. Now find out charge Q. Q is equal to C into V. Find out charge
2.95 into 10 raised to minus 5.
2.95
95 into 10 raised to minus 5.
10 raised to minus 5. Okay. Unit. Unit of charge.
Coulomb.
Coulomb.
Coulomb,
Coulomb.
coulomb.
Yes.
Coulomb.
So it is, we can write 29.5 microcoulomb, okay? Or 29.5 into 10 is to minus 6 coulomb. Okay, all of you getting this answer? So this is C and V is
Yes, sir.
given 1000, okay? So this is, the answer is 29.5 into 10 is to minus 6 coulomb. Now find out flux density, D. D is equal to Q by A.
1.475 into 10 raised to minus 5.
1.475 into 10 raised to
Minus 5.
minus 5. What is the unit of flux density?
Coulomb per meter square.
Coulomb per meter square.
Coulomb per meter square. So answer is 14.75 into 10 raised to minus 6 coulomb per meter square. Okay.
Yes, sir.
Yes, sir.
So Q by 429.5 into 10 raised to minus 6 by 2. So the answer is 14.75 into 10 raised to minus 6 coulomb per meter square. Now, here ask, find out dielectric strength for each slab or each dielectric medium. So you have to go for E1, E2 and E3. Okay. So E1 is equal to D upon epsilon into epsilon R1. E2 is equal to D upon epsilon 0 epsilon R2. So E1 is equal to D upon epsilon 0 into epsilon R1. So D is equal to 14.75 into 10 raised to minus 6 divided by 8.854 into 10 raised to minus 12. So this you have to remember epsilon 0. Okay. And this is 2 permeability is given for the first dielectric medium. So the answer is kV per meter for first dielectric slab. For sec, tell me if E2 what you are getting. E2 is equal to
555.3 kilovolts per meter.
55.3 kV,
550.
kV per meter. E2 is equal to D upon epsilon 0 into epsilon R2. So you will get 555.304 kV per meter. If you are shifting this point, decimal point, then accordingly you need to write this unit, okay, or you need to substitute by this 10 raised to power, okay. You can write this kV per meter. Suppose you're shifting this point, decimal point, then you need to multiply by whatever 10 raised to positive or negative power. And what you're getting E3?
277.6 kV per meter.
277.6 E3.
Yes, sir.
Yes, remaining one. All of you getting this 277?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay, so you need to do practice for this solution for getting this answer. So then and then you can manage the time in examinations. Okay, if you are not doing practice, then for the one example, you will spend 30 to 40 minutes. So that's why just I am saying you just do the practice for getting the answer. Okay, for solving these examples. Then otherwise you will not complete your question paper in examinations, because in examinations you will be having 50-50 percentage weightage, 50% examples and 50% theory, or 60% example or 40% theory. Okay, and E3, that is 277.652 kV per meter. So this is for the capacitance and different dielectric strength. A capacitor is made of two plates with an area 11 centimeter square, which are separated by mica sheet 2 mm thick. If relative permeability of mica is 6, find its capacitance. If now one plate is moved further to give an air gap 0.5 mm between the plate and mica, find the change in capacitance. So here two cases are given. In first case, what given? Which dielectric medium is given for the first case?
Mica.
Mica.
For mica, it is called uniform. We have only one type of dielectric medium. Okay, so it is called uniform dielectric medium. Now we are adding this air gap along with this mica sheet. So what it is called for second case? It is
Partly air.
yes, partly air medium. Okay, so here we have to find capacitance for the both cases. Okay, so suppose you want to show it in diagram, then it can be drawn like this. For the first case, we have only this mica sheet, so that is 2 mm thick. Okay, and for the second case, we have that this mica sheet, and along with we are adding this air gap of 0.5 mm thickness. Okay, so this is the second case. So in both the cases, we need to find capacitance. So for the first case, we know what is the equation for capacitance? C is equal to
Ka epsilon naught by D.
C is equal to epsilon 0 into epsilon r into A by D. For the first case, for the uniform dielectric medium, C is equal to epsilon 0 epsilon r into A by D. You have the equations for the uniform. You can tell me which dielectric medium has highest capacitance? Uniform or this by adding air gap? Which case has uh, highest
Uniform.
capacitance? Yes, for uniform.
Uniform.
For uniform,
Uniform,
you
sir.
get the highest
Uniform.
capacitance. Yes, uniform. So the capacitance is given by for the first case C1 is equal to epsilon 0 epsilon r A by D. So epsilon 0 equal to 8.854 into 10 raised to minus 12 into epsilon r is given, that is 6 into 11 into 10 raised to minus 4. Okay, it is converted into meter square. Centimeter square is given, so convert into meter, so it is 10 raised to minus 4 divided by this thickness is given 2 mm, so convert into meter, so 2 into 10 raised to minus 3. So by calculating this, we'll get 29.21 into 10 raised to minus 12. 10 raised to minus 12, that is your picofarad. Okay, just remember this. Yes, you can write this 21.9 10 raised to minus 12 farad also. Okay, but if you know the conversion, then just write 29.29 picofarad. Okay, now this is for the first case. For the second case, you can use these equations, or you can use other equations also, d minus t by, okay, or here 2 medium is given, then you can use this equation also, epsilon 0 into a by d1 upon epsilon r1 plus d2 upon epsilon r2. Okay, so by substituting this, you will get C2 is equal to 11.68 picofarad. Are you getting this answer?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes. So in C1, you can see here we have 29.29 for uniform. When we add the air gap along with this mica, then capacitance you can find here 11.68 pico. Okay, so this is the capacitance for different case given for the dielectric medium, then you can go for it. Now capacitor in series. So we already derived resistance in series and resistance in parallel. Now in capacitor it is opposite. Okay, so when you have capacitors calculations, then you need to consider for the if parallel connection is given or series connection is given, then your equation will become reverse. That we'll see, okay? So here we have three capacitors C1, C2 and C3, and Q charge is given for all three capacitors. So as for the series connection, we have charge remains same for all three capacitor, okay? And the voltage remain different for the series connection. So V1, V2, V3, that is across three capacitor, okay? So C1, C2, C3 capacitance of three capacitors, V1, V2, V3 potential difference across three capacitor, V applied voltage across the combination and equivalent capacitance of the combinations, okay? So same assumption according to the series connections, current remains same and potential difference that is different for the series of capacitor. So we know V equal to V1 plus V2 plus V3, but according to Q is equal to CV, we can write V1 is equal to Q by C1, V2 equal to Q by C2, and V3 equal to Q by C3. We can write V is equal to Q by C. So V is equal to Q by C1 plus Q by C2 plus Q by C3. Okay, this V is equal to applied voltage. So if C equivalent is the equivalent capacitor, then we can write V is equal to Q by C equivalent. Okay. So here just we are substituting Q by C equivalent. Then for the series connections, we have 1 upon C1 plus 1 upon C2 plus 1 upon C3. Okay, so don't make mistake when capacitance connected in series. So you can write 1 upon C1 plus 1 upon C2 plus 1 upon C3. Okay. So this is for the capacitance connected in series. So you can write equivalent capacitance. If n capacitors are connected, then you can write these equations, okay? 1 upon C1 plus 1 upon C2 plus 1 upon C1. Now for the parallel, so you can see three capacitors connected in parallel. Now current is different, okay, in parallel combinations, whereas voltage remains same across all three capacitors. So we know I is equal to I1 plus I2 plus I3. Now multiplying time on both sides. So I into T is equal to I1 into T plus I2 into T plus I3 into T. But we know charge is also given by Q is equal to I into T. Okay. So just we are substituting here. Q is equal to Q1 plus Q2 plus Q3. So Q is equal to IT. So Q1 is equal to C1 by C1 into V, C2 into V, C3 into V. So just we are substituting here. So just taking V common, C1 plus C2 plus C3, and here suppose we have putting Q equal to C into V, so V we cancel. So we are getting C equivalent is equal to C1 plus C2 plus C3. So this is for the capacitance, capacitor connected in parallel. So you have to write C1 plus C2 plus C3. Okay, anyone having query for capacitance in series and capacitance in parallel?
No, sir.
Okay, now we will go for the examples. If capacitors connected in series and parallel, then you need to find capacitance and charge. Okay, this is for the n capacitors connected in parallel. So you can write this expression. Calculate charge and voltage of each capacitor. So here C1 and C2 connected in parallel combinations with this 9 microfarad that is connected in series with this parallel combination. V1 and V2 that is different for these capacitors and 200 volt applied between or this applied across the capacitors. So we need to find charge and voltage V1 and V2 of each capacitor. Okay. So just find out this equivalent capacitor of C1 and C2 as it is connected in parallel. So what we are doing for the parallel connection of capacitor?
C1
C1
plus
plus
C2.
C2.
C1 plus
Yes, C1 plus C2. So here equivalence capacitance of C1 and C2. So just we are giving the name Cp is equal to C1 plus C2. So this is a 9 microfarad. Okay. So this 9 microfarad and this 9 microfarad now in series combination. Okay. You can see and C3 and 200 volt. Now these are in the series connections. So Cp and C3 are in series. So total capacitance of the circuit. So C equivalent is equal to Cp into C3 divided by Cp plus C3. Okay. So we have 4.5 microfarad. That is your equivalent capacitance. Okay. Is it right? We have only two
Yes,
capacitors.
sir.
We can write okay plus Cp plus 3. Now charge, we know charge equal to Q is equal to Cp into V1 is equal to C3 into V2, as we know charge stored in series connection that is remain same. So Cp into V1 or this C3 into V2. Okay, this voltage is given different for each combination. Okay, for the Cp across Cp we have V1 and across C3 we have V2. So we can write this charge Cp into V1 is equal to C3 into V2. So just rearranging the equations, V1 by V2 is equal to C3 by Cp. So we know this C3 and Cp. So that is 9 by 9 equal to 1. So we can say V1 equal to V2. Okay, up to this. Now we have to find this V1 and V2.
E is
So
equal to V1 plus V2.
yes. So according to say this 200 volt is given, then here we got V1 equal to V2. So what we will get?
V1 and V2 are 100 watt.
Yes, 100 volt. Yes, good. So as we know, V1 plus V2 equal to 200. So we can write V1 equal to 100, V2 equal to 100. And this total capacitance is given. So total charge Q equal to into CV. So this is 4.5 into 10 is to minus 6 into 200. So this total charge Q is equal to 900 into 10 is to minus 6 coulomb. Okay. So here we found charge and voltage across each capacitance. Any query in this example?
Sir,
No, sir.
parallel.
Yes,
We can
yes.
do something
If you have to
like
find the voltage branch in parallel, then
In parallel.
yes.
So that we'll see. This is given series combinations. This is given series combination. Okay, so that's why we have go for this. Parallel combinations, you have to go for this uh, different methods that we will see for the parallel combinations. Okay.
Okay.
Okay, we will see for the parallel combination also.
uh,
Yes. Yes.
if we find a C equivalent first and then we find total charge, then in a series the charge on capacitor is equal. So we get the charge on the third capacitor and then we can find voltage. Our whole sum is done in some 2-3 steps only, no?
Yes, you can go other method also. Okay, it is not necessary that you can follow this method also. Okay,
Okay.
you if you know the relationships, then you can go by other method also. Okay.
Yes, yes.
So I am writing step by step, and you can just go. You can follow the other method also. Okay, and just get the correct answer.
Okay.
Now, when two capacitors A and B are connected across 200 volt DC supply, the potential difference A is 120 volt and B is 80 volt. The PD across A is rises to 140 volt when B is shunted by 3 microfarad capacitors. Calculate capacitance of A and B. Here two cases are given. In first case, what given? When two capacitors A and B connected across 200 volt DC supply, The potential difference across A is 120 and B is 80 volt. Okay. The PD across A is now rises to 140 volt. Okay. Here in first case, what given 120 volt. Then second case, this is rises to 140 volt and B is shunted by 3 microfarad. So shunted by means we are adding 3 microcapacitor in parallel with B. This shunted means we are adding 3 microfarad capacitor in parallel with this B capacitor. Okay. So calculate the capacitance of A and B. So this statement is converted into diagram. So this is the first case, C1 and C2 connected across this 220 volt. 120 is given V1 across A, V2 given across B. Okay. So for the case 1, A and B in series, so charge across each is same. So C1 V1 is equal to C2 V2 according to this Q is equal to CV. So we know 120 into C1 voltage given 80 into C2. So we are getting here C1 is equal to 80 upon 120 into C2. Okay. So that we will use in next step this relation. Now in second case, you can see this C1 is rises to 140 volt and B is shunted by 3 microfarad. So here we are adding 3 microfarad capacitor in parallel with B. Shunted means we are adding in parallel. Okay. You can say shunt connection or it is shunted by this. And this is 80 volt. Okay. Case 2. So 3 microfarad and C2 are in parallel. So total capacitance of parallel circuit C equivalent is equal to C2 plus 3 microfarad. But this combination now, after getting this equivalent, so this equivalent and C1 are in series combination. Okay. So charge across each must be same. So what you can write 140 into C1 is equal to 80 into C2 plus 3. Okay, according to Q equal to CV, charge must be same as these are in series combinations. So this 140 into C1 is equal to 80 into C2 plus 3, but we know the relation. We got this C1 is equal to what we got here. Okay, wait.
Sir, C1 equal to 12
Okay, wait.
microfarad.
C1 is equal to 80 upon 120 C2. This we are substituting in the equations. So 80 upon 120 into C2, we are substituting. Okay, C1 equal to. So C2 is equal to 18 microfarad. Are you getting 18? C2?
Yes. Yes, sir. Yes, sir.
And we know the relation C1 is equal to 18 upon 120 into C2. So C2 just substitute 18 here. So we'll get 12 microfarad. C1. Okay. C1 is equal to 12 and C2 equal to 18. So whatever combination is given series of parallel. So according to that, you need to find this equivalent capacitance and accordingly you can write this charge stored equation. Okay. So this is C1 and C2. Now this example is given. Two capacitors having capacitance of 6 microfarad and 10 microfarad are connected in parallel. A 16 microfarad capacitor is connected in series. With this combination and complete circuit is connected 400 watt. Calculate total capacitance, voltage across each capacitor, total charge in the circuit and the charge on each capacitor. So two capacitors having capacitance 6 and 10 are connected in parallel. Okay. Now here parallel combination is given and a 16 microfarad capacitor is connected in series. So 10 and 6 in parallel, that is in series with 16, and 400 volt is applied. So this is the diagram. So you need to find total charge. You need to find the charge on each capacitor Q1, Q2, Q3. Okay. You need to find this V1 and V2 voltage across each capacitor.
Sir, in the
Yes.
question it is not
8
mentioned
microfarad.
that the capacitors are in parallel, then we have to assume that it's in series, right?
What?
If the question is not mentioning that the capacitors are in parallel, then we have to assume that they are in series.
Yes, yes. If it is not mentioned, then it is in series. Okay.
Okay.
Yes. So whatever data is given accordingly, you have to follow this method or procedure. Okay. And you can do also circuit diagram. But or whatever mentioned that you have to consider. Okay. So this example we have done. Okay. So step by step, you can follow by your method also, or you can follow step by step. So C1 is given 6 microfarad, C2 10, C3 16. Now equivalent capacitance of C1 and C2 parallel connections. So we have 16 microfarad. Okay. For this C1 and C2, this 16 and this 16 is in series. Now total capacitance C equivalent is equal to, these both are in series connections, so we can write 16 into 16 by 16 plus 16. So that is 8 microfarad. Okay, total capacitance. So this is your first. You need to find total capacitance of the circuit. So total capacitance C equivalent is equal to this parallel combinations. So 8 microfarad. In series, the charge is same. So you can write V1 into C12. This is equivalent capacitance of two parallel capacitor and is equal to V2 into C3. So we can write the 16 by 16 is equal to 1. So we can write V1 equal to V2. But we know V is equal to V1 plus V2. So V1 equal to V2 equal to 200 volt. So voltage across each capacitor. Third, total capacitance C equivalent is equal to 8 microfarad. So charge, total charge Q is equal to C equivalent into V. So that is 8 into 10 raised to minus 6 into 400. Okay. So the answer is 3.2. Okay. Same, you need to find charge on capacitor Q1, Q2, Q3. So C1 into Q1, C2 into Q2, C3 into Q3. So this voltage charge on capacitor C1, C2, C3. So Q1, Q2, Q3 is given C1 into V1, C2 into V1, C3 into V2. As this V1 remains same for the C1 and C2, okay? And for C3, we have V2. This written, that means what? 1.2 you can convert into this also, okay? It is in millicoulomb. You can write 12 into 10 raised to minus 4 coulomb or 1.2 millicoulomb. Well, that is your 10 raised to minus 3. So just we are writing 1.2 into millicoulomb, or you can also write this 12 into 10 raised to minus 4. Are you getting this answer? Q1, Q2,
Yes.
Q3.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay, so this is for capacitance in series and parallel. So you need to find equivalent capacitance charge stored in capacitor. You need to find voltage across each capacitors. So you can find out by these methods, okay? So in next lecture, we'll see. Okay, this is not in your syllabus. I will not ask this derivation in examinations, but you need to remember these equations. Energy stored in capacitors, that is given by 1/2 CV square, or you can write 1/2 QE, or we can also write Q square by 2C. Okay, so there are three equations that you have to remember when we store energy in the capacitor: 1/2 CV square, 1/2 QE, and Q square by 2C. Okay, so after that, again, we will go for the examples. If series and parallel combination of capacitor is given, then you need to find this energy stored in capacitor. So you have to use these equations: 1/2 CV square. Okay. Then charging and discharging we'll see in practical. Okay. So these derivations will not ask in examinations. This is for your practical knowledge. So that we'll see how this capacitor is charge and discharge. Okay. So no need to remember this derivation. But what equations we are getting, that we will see. Okay, for the charging and discharging. Okay. So anyone have query doubt regarding to this?
Sir,
Yes.
in assignment in question 30, area is not given.
In question number.
13
13.
area नहीं दिया.
Okay. So I will.
Sir, area is not given.
Okay, I will see the data and I will provide you area. Okay, if not given.
Okay. Okay, sir.
So now you may leave the session.
Thank you, sir.
sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.